All right, I'm going to bring Caleb on to share K3s.
Thanks, Jerry.
Yep.
All right, I'm Caleb. I work at Snady as well. Normally, I'm working on NGS or Helix, but today I am the founder of the Edgy Coffee Corporation, and I'm going to show you how I'm going to use NATS at the edge to run K3s clusters at my store. So developers love coffee. Thought coffee would be a great example. And what we're going to do today is run K3s clusters, and then we're going to use what's called the NATS JetStream driver in Kine to run those clusters. So what Kine is, for those of you familiar with Kubernetes, Kubernetes out of the box speaks to etcd for its data store. And what Rancher, now SUSE has done is when they built K3s, they built a layer, a shim, an etcd shim essentially, and that is called Kine. It actually stands for Kine is not etcd. So one of those fun recursive algorithm or acronyms. But community member Matt Deviney actually contributed this Kine driver that backs Kine to NATS JetStream. He actually found that, hey, JetStream, the KV implementation in JetStream has a similar API to etcd, and this landed in May 2022, so it's in all of the recent K3s releases. So let's hop right in. Like I said, I'm running a coffee company. I want to have clusters running at the edge over at my distribution center and store. But if you're in any of these other, pretty much any industry that has like regional edge, local edge setup, you could have a very similar setup. Just replace distribution and store with what relates to your industry. So let's do the simplest implementation here, which is we've got one NAT server running JetStream, and then we've got one store in New York City. So I'm kind of cheating. I'm not actually going to run these out across a distributed network. I'm just going to run it all locally in separate containers, but we'll name the containers after where they're supposed to be geographically, and then we'll show a map to have things pop up. So this first NATS cluster, I'm going to put that in Chicago, and then my store is going to be in New York City. So I've already kind of pre-created this NATS cluster, so let's just go read the logs off of that. I'm running the latest NATS server. I'm running JetStream. That's pretty much all I need. There is an account configured for this New York City store. And the next thing I'm going to do is set my location to New York City. All right. And then I am going to create a K3s cluster. Now I'm using K3D for this, so it's running K3s inside of Docker. So let's run that cluster creation. I'll show you what that looks like. So we're basically starting a K3s cluster, and we've supplied some arguments to this cluster to disable certain components because we just want a simple cluster to run a simple workload. And then there's this data store endpoint argument, which you can see the scheme is nats:// I've got a username and password protected, but this driver does support any kind of authentication that NAT supports. And then I've set a KV bucket name, which is US NYC. Now that command's done running. Let's go query this NATS cluster and see what we have. All right, we've got a US NYC KV bucket, and it's already got 528 kilobytes of data in it, which is awesome. That means that etcd data is running in there. We're just going to make sure that this cluster has started up completely, which it has, and then we're going to list all of the resources in this cluster. So you can see that our cluster is running happily. We've got like core DNS running, but I want to install an app for my coffee company on here. So I'm going to install this very basic app. So let's just go look at this app manifest real quick. So this app manifest basically says every second, or I think it's every 10 seconds, it's going to publish just a random quantity of bags of coffee that I have in inventory. So very, very simple app. And it's going to publish that from this workload running on this cluster in New York City. It's going to publish that up to Chicago. Let's just go ahead and get the logs on that app. Great. So that looks like it's working. Which this is all cool, right? And then the next thing I'm going to want to do is run multiple clusters, right? So I've got a coffee shop in New York City, coffee shop in LA, my distribution center in Chicago, and I want to do some analytics on the edge. So I'm going to run workloads at the edge. So I actually want to run 3 clusters, but back them all to the same NATS server. So I've kind of cheated just for the sake of time. I already ran this for my Los Angeles location, for my Chicago location. So if I go list my clusters, I do k3d clusters list. Cluster list. Great, I've got 3 running. So Chicago, LA, NYC. Which again, this is great because all my data is going to the distribution center. But now, sitting back up at my home office, I want to get insights into this, and I don't want to VPN to my distribution center to go look at this. So what can I do there? Well, how about I extend to the cloud? I know we've been using NGS a lot today, so I'm going to use NGS as well. You can see I already built a web app here. I'm connected to NGS. Now all I need to do is connect my distribution center to NGS. So I've already created my account on NGS, and all I have to do now is basically reconfigure my NATS server here and have it point to NGS as a leaf node. So let's check our logs to make sure that happened. We should be able to see, yep, we've got a leaf node connection created. And then all of our stores have popped up. So we're reporting inventory from Los Angeles, New York City, Chicago, and these will change randomly every 10 seconds as well. All right. So there's a lot of other scenarios that we can do here. I'm just going to show one more real quick, and that's going to be the backup restore scenario. So I'm reporting my inventory data all the way up to NGS, but another thing I can do here is I can actually mirror all of my streams to NGS. So all of that data that's getting all of that k3s data that's getting backed to my distribution center, I can actually send all of that to the cloud. So that is now in NGS. If I do NATS stream list, NATS KV list rather, since these are KV buckets, you can see that I've got all of those KV buckets mirrored up to the cloud. Now, let's say, I've been helping out in the distribution center over the weekend, and I dropped a pallet of coffee on my server stack, so that whole thing got crushed completely. Here's something I can do. I can actually take backups of all of these streams out of the cloud. I can completely destroy, my cluster that's running in Chicago there. So I'm going to shut down my k3s clusters. I'm going to destroy my NAT server in Chicago, destroy all the data running on that. Okay, recreate that. And there's actually just a small thing I have to do real quick. I have to go into these backups and just remove this mirror. I don't want to recreate these KV buckets as mirrors. I want to create them as actual KV buckets. So remove these mirrors. And all right, copy my backup files over to my new server. And then just watch how quickly we can restore this data. So 1, 2, 3, bam. all of our data has been restored into our NATS server in Chicago there. And the last thing I'm going to do is start my K3s clusters back up. And over here, I'm going to refresh this page. This is always the most nerve-wracking part of the demo is hoping that this data comes back. It's always worked for me, but it takes probably about 20 seconds. Of course, these K3s clusters have to start up, read, the container specs that they were supposed to be running. Let's just look into one of them real quick. All right, let's go look at our kube control get pods. Bam, we've got our app that we had, deployed a manifest to before. Completely wipe that out, restore to backup from the cloud. You can see that has one restart. And then as these clusters come back online, 1, 2, 3, all of that state had been persisted, is now back in action, and I'm back up and happily running. Of course, it doesn't have to stop here. You can get as fancy as you like with this. You can go completely global, multiple distribution centers. You could run NATS down at the store level. You could have one store talking to the store next to it. You have so many options that you can put into this architecture with NATS. You can feed in data from the top as opposed to pushing it all up through the bottom. So really the possibilities are endless, and I can't wait to see what people come up with and hear about some of the architectures that you use. Of course, this is open source demo. You can go get it at connecteverything/K3s on NATS.
This is
So
awesome.
let me know how it goes.
Thanks so much, Caleb. Yeah, this is so cool, and it's a use case that we want to continue to try to solve for more in the future with better tooling and everything like that. We think NATS is a really good fit for being able to kind of do this like fleet management use case, being able to solve like how do we do multiple distribution centers or multiple Kubernetes clusters and K3s and Kine and NATS. It feels like there's a lot of opportunity there, and it's cool to see that it can be modeled today. And I can't wait to see what we can find in the future as we continue to develop these tools. So thanks, Caleb, so much for the time and for sharing. Really, really awesome demo.